Hello everyone, so I'm back with another tutorial. This time we're going to implement a variable length chain. So let's see it here. So we have it here. We have two points that we can manipulate to manipulate the length chain and the position. So as you can see here. So if we simulate right now, you'll see that we have a chain, complete chain that interacts with everything. And it's completely simulated using physics constraints. So by the way, things that you use here are actually part of the toolkit that I made, a physics toolkit. It has a bunch of stuff in it, as you can see. You have fields, you have different components, you have switches, you have when generating stuff like this, and you also have a simulated character. This is it has simulated capsule, and it's completely and simulated from the bottom up. So if you want it, I put a link in the video description so you can it's available on Fab, so you can get it there if you want. But continuing with this, so the chain, it's basically these 2 points that you can manipulate to set the length and the position. And let's go ahead and look at the options here. We have a few parameters. So one of them is the link scale. So if you can, then you can like make a bigger links if you want. Let's put it back. And then you can adjust the distance between the links as like this. This usually when you set the scale, then you set the distance between links also, so it becomes more natural. So let's set it back. You have physics constrained link offset. Then it's the offset that you have from for the physics constraint. I can explain this later. Then you have link constraint mode. So this is like if you want it constrained to a certain plane, as we have here for a side scroller, then you can set this to plane, as you can see it here. Then we have the physical material for each link. We can configure it here, and we have link mass. This is important when you interact with other object. The mass is very important, how it interacts. Yes, and then you have the points at the beginning and the end configured here, this one and the other one, and that's it. That's basically it. Those are the options. So let me just show you the blueprint quickly. So it's quite a simple blueprint. Let me see here. Chain, what was it? Chain blueprint. As you can see, so we have the mesh. I will provide it here and in the description. And then you have it's just a simple blueprint class that you create. And then when you go into it, you have these components that I will talk about. You add them, and then you have the variables. So that's it. Just wanted to show you quickly. This is not, it doesn't have any special configurations. It's just a blueprint. So let's go into it and let's see the details, and let's see how we can implement this. So first of all, we have kind of everything that you saw before, all these configuration variables here. Just make sure that for the beginning and the end here, you set the show 3D widget. This is very important, so otherwise you don't see this manipulation widget here. So that's very important when you create these. And then what we have here are the components. So you have what I've done is I've actually so these links are generated. We'll see they're generated in the construction script and the physics constraints also. But the first and the last link, I actually created them here. And why is that? That is because so you can, as you can see here, when we attach, you have just a block here, and then we have a physics constraint that attach this block to the chain. So as you can see, it attaches here. So you have to give it the first, this is the ledge, and the second one is the variable chain, and then you have the component link that you have here, first link. So this, I chose to do this because otherwise we cannot really access the other ones, or it's not easy to access them. So this is why the first and the last then are done like this, so we can attach a physics constraint to it. Okay. So we have these two first here, and then we have link attachment. So this is the physics constraint that is used for each that is going to be copied for each link to be attached to one another. So let me show you how this here. I guess you can just copy this. So it's not configured to any component because this is just, it's going to be destroyed afterwards. It's going to be copied and destroyed afterwards. So these are become configured in the construction script. But here we can look at how the linear limits and the orthogonal limits are set. So we have the X motion, as you can see here, is limited. The other one is locked. And then you have the swing and swing 1 and 2, and you have these limits. So I'll let you have a look here. So this is so that the chains rotate normally and naturally within each other, as you can see. Okay, so let's go ahead then and we'll go and look into the construction script. But first, as you can see, so there is a physics constraint. Because it's generated in the construction script, we cannot select it here. But as you can see, there's one constraint to each link, and then links one chain link to the other, and it's that simple, and this repeats. So that's what we're going to see in the construction script. So here I just made a function and just construct the whole chain. So if we look into this, then we have just several steps that we can, like we do here. And let's go ahead and look at them into detail. So first, I'll go into detail for each one of them. Then let's first understand what we do, like big chunks. So here we place the first link, which is this one. It's already created here. Then we configure it. Then what we do, we make a loop for all the other links. And here we say, okay, if it's not the last link, then we just create all the other links in between. If it's the last link, then we go here and we configure the last link. And this is different because the last link also already exists. It's a component that already exists here. So then after that, so this is this whole thing until the end is just in the loop here. This is only, sorry, in this loop. And this is just a branch, right? So then it gets merged here, and so here what we do is we take the links that are perpendicular to the other ones, and we just rotated them. Let me see. So it's here. So we rotate those with an odd index. Then we just configure and create the physics constraint. And then we finished here. We remember the previous link, so we know it for the next iteration right here. Okay, so those are really the big steps. So let's go in the beginning and see what we do here. So we have the two locations here configured. It's for the configuration here, the beginning and the end. So here we get the chain direction. This is a vector that just a vector of 1, which indicates the direction. And this is, you just subtract and then you normalize, and then you get this vector. Remember this one as a local variable here. because we use it to align the links, right? Okay, so then let's configure so here we configure the first link that already exists. So we set the transform. So we have here, we said, okay, we need a location for it. So we take the distance between links, and then we multiply it as the chain direction, as you can see, and then we add it to the begin location. So the begin location is the one that we configured. So this sets the chain link location. So just as I will gonna put a link in the description for the chain link, so you can use it directly as just a static mesh like this. So nothing really fancy, and it has a collision. What was that? Show collision. Yeah. So just you can do your own collision. What I did here is that you have a collision with the just hull like this. Okay. So so you can download it from the description. So here you set the location like this, and then you set the rotation. We create a rotation from the X direction here, and then the scale. Well, link scale. This is the variable that we set here, link scale. So that's it. So so this is the transform of the link, the first link. Now we have just a reference here to the first link, and then what we're going to do is we override the material, right? So this is physical material. We input it from here. Then we set the constraint mode. So this basic stuff that we configured. Constraint mode again. So it's to what kind of plane this is constrained in the world. Then we set the mass here. This is important also. And then, so we set the previous links, so then we use it for the loop here. So that's it for the first link. Really, really simple, right? So I'll just let it, so you can look. Okay. So here we set the overall mass, just so that's important. Otherwise it won't, I think it will add the mass or something like that. Okay, so here we have the big loop that goes through here. So let's look at the loop before. So what we do here is we cut the loop in different sections. So here, as you can see, we subtract, we get the distance between the beginning and end, and we divide it with the distance between link. This is the variable here that defines that. And I can, let me show you quickly values for this. So you would know, let me see. Sorry, here. Yeah. So you have 3 here, then we have this 17, and then 325 PVC link offset, right? So there's some values that you can use for the variables. Then you can play around with them and see what happens. And here we subtract because we have the first and the last link already there. And then, so we begin the loop here. This is only the branch that we use to know when we reach the last link. So if it's true, then you go here instead of all the other links that will be created here. So for all the links that are in between these ones, we have create link. It is a function that I created. So we have a reference for the previous link, and we get the word location, and this is going to be used to place the next link. And we also have the vector of the chain direction. So if we go into the function here, the create link, looks a bit complicated, but it's really simple. So we have the word location of the last link here and the chain direction. And here we'll add a static mesh. So we create something like this here. Then we have to give it the transform. So the location, we just add the location. So basically we add the distance between link to the, as you can see, we multiplied it here with the chain direction, and we add it to the last location. So we calculate it based on the last one. And then you have the rotation, which also it's like from X rotation, from X axis, and the transform, you have the link scale. Sorry, for the scale we have the link scale, which is input is the this one. So like all the other ones. And then what we do, set constraint mode as before. Now here what we have, we set the static mesh of the component. So this we have created a static mesh component, but here we have to give it a static mesh to this component. So as you can see, we take the static mesh of the first link and then we put it here. So basically we copy everything from the first link. Same thing with the mass, then we set the mass of the first link. We set simulate physics, so it simulates the physics and it's not a static object. Then we set the material here. If you have multiple materials, stuff like that, then you may want to change, but this is just one material, so we set it here. And so then we set the physical material as an input. So that's it. So basically this all copies stuff from like external variables, as you can see here, and the only one that is really calculated is this one, where you set the position and the transform, right? So yeah, that's it, nothing else to do here. So if we close this one, we go back. So this is what we saw, and it's the exit here. It's actually, if you look, what was it? So it's the static mesh component that we created, one like this, but like the static mesh component of the link itself. So this is exited, as you can see, exits here, created link. This is a reference to it, and then as you can see, we'll use it here in the next part. Now, in the case where we have the last component, the last link, which actually exists already here, we execute this one, this branch. So this is normal, and this is at the end. So here, if we look for the last link, then we have the reference for it here for the component. We set the transform. Again, we take here the distance and multiply it by chain direction and add the previous link. It's basically the same thing as what we saw here, right? So then you set the physical material. Well, this is weird. It should be like this. I don't know what happened here. Yep. That's an error. Okay. Yeah, so forgot about this. So we set input variables here, physical material, the mass, and then the constraint mode. So it's very similar to this one. So then we finish this part, and then as you can see, they merge together the flows here, and what we have, the index here is it. So as you can see, if this is true, and that means it's the last one, well, as you can see, we have a select. So if it's the last one, we take this one, If it's in between, then we take this one. So we take the reference here or the last link. So that is, so we take the right reference for this one in depending on whether it's the last link or the other ones. So here, then we're gonna rotate the odd links. So as you can see, they have, one of them is horizontal, the other one is vertical. So here we have the index. This is the index from the loop right here. It goes like this, and we do a modulo 2. And then if it's greater or less than 0, then that means it's odd or even, right? So based on this, we select if it's true or not. And if it's the odd indexes, then we add rotation. That means we shift like vertical to horizontal. And as you can see, we have delta rotation here. We just add it to the X axis and that's it. And the input is based on this, right? So it's either comes from this for the last link or the bottom from all the other links. Okay, so this is it for rotation. And then last thing, we have the physics constraints. So we've placed the link until now. All the links are placed, but now we have to put the physics constraints here. So what we'll do is actually copy from this one and then place it. That's it. So as you can see here, we add the physics constraint, we set the transform. So we have the math for the transfer here. We have the previous link. So we set it relative to a previous link. We have PC, which is physics constraint link offset. And this one will apply, it's an offset from the last link that we add here, and we just multiply to the direction of the chain link, as you can see here, and add it, and that gives us the location of the physics constraint. So basically, this one, for example, it's the last link, which should be this one, and so you shift it from that one, right? So that's it. It's very simple. This one you will, if you configure, by the way, the size of the links, then this one will have to be changed also, so you can shift. Well, actually, no, you don't. They will shift normally. No, sorry. No, this I only put here so that you have some, if you really want to check this, to fine tune this, really, you can do that, but you don't have to. Sorry, that was a mistake. You don't have to change it if you change the link scale. So same thing for rotation, and now we've created it. And then what we want to do is we want to configure it. As you can see, we take the the reference to the physics constraint and the previous link and the current link, and then we give it to the physics constraint to configure it. So let's see here. So it's a lot of stuff here, but it's actually really simple. Let's go on the first one. So this is just a sequence. We do first this one and then this one. That's it. It's just to simplify things. So here, well, we have a physics constraint. First we attach let me see here. We attach the physics constraint to the previous link. So that means its parent is going to be the previous link. That's why I've seen it works better, right? So this is what happens. These settings are important. Keep world and snap to target, all that. Make sure that you set exactly like this. This is important. So then we set the constraint components. So this is where we really configure the physics constraint. So as you can see, we have this one, the previous link, and then current link. That's it. and then you set disable collision between them on the physics constraint. That's so they won't collide. Now theoretically they don't, because I've put we have a hall here of collision, so it's actually it's open in the middle. But the thing is that the physics constraint, as it's configured like this, as you can see, even if they don't collide, they will not collide because it's configured so it rotates up to a certain point, and this also. So they will never collide if you simulate this, right? Even if it's this collision disabled. Why I do this is because what happens is usually you have less errors like this, right? So you don't have like ejection forces and stuff like that. Because even if they go a bit over, it's not that big of a deal. So this is the first part here. We attach the physics constraint to the previous link. Here, as you can see, it's a parent, it's a previous link. Then we set the two constraint component, and then we disable collision. Now here, what it's basically we copy the properties, all the properties that we need from this one. So you see in the physics constraint here, we say get constraint. The constraint is actually it's actually a property, the variable in the physics constraint component. So this is the component. If you look here, it's a component reference. So we actually get the constraint in that component, the constraint itself. So this will let us copy the properties, because otherwise from the component we cannot copy them. And I've looked into this, and there is no other way to actually copy them. Maybe there is in C++, but in Blueprint it doesn't work. So you have to do this manually, as you see here. There's no like copy function or anything like that. So it's a bit of a bummer, but that's it. So here you get the constraint from the current physics constraint, and here you get the constraint of this one from which we copy, right? So the current link constraint is here and on the top, and the constraint that we copy from is from the bottom. And then so you get linear limits, get them, set them. As you can see, you set them on the top here. Also for angular limits here, you just copy them, you get them from the bottom, so from this one, and then you set them on top. So that means each physics constraint. Angular drive mode, angular drive parameters, angular velocity target, and angular orientation target. So of course physics constraint has a lot more stuff in it. If you want, you can copy those if you really need them. In my case, I didn't. So I've kept a really simple configuration for this. So yeah, that's it. So this is it for the copy of the configuration of the physics constraint, which we copy from this one. So if we go back into the construct chain function, this is basically the last step here, and then we just remember the previous link, and this is as you can see, it's a local variable here. You have all the local variables in this function here, and that is because when we finish like this, we just go back to the loop here, and it does it again, like for every link, right? So everything that you see here like this is done for each loop, right? So that's it. That's the whole thing. Now, so let me just show you quickly here. So make sure that you put this show 3D widget, expose on spam, everything like this. It's important. Same for this one. And here you just have, as you've seen, some variables. These are different, it's just default, but I have different values there. You can play around with them. Yeah, so just showing a bit here. Have the components, which you can see here also. So that's it. It's almost 100% done in construction script. So now what we can do is just have a look at the, so again, these are the three functions. You have construct chain, which is this one, the whole thing. And then you have configure physics constraint that we saw here, this one. And we just have create link that you saw here. That's it. These are the three functions. And if you look in the begin play, the only thing you'll see, and this is not absolutely necessary to do, but I've actually destroyed this one. It's just the one that we copy from all the others from, and just so we don't, like, you have less physics constraints. Yeah. So it's just, I don't know. I mean, you can leave it, because normally if it's not linked, that won't do much, but I decided to destroy it here. So yeah, that's basically it. Let me show you here the last link, how I configured. So you have static mesh, you have material here. So yeah, it's a normal thing. I have a mass set here, but we overwrite it later, so it doesn't really matter. Make sure you click generate physics here for both of them. So yeah. So if we go back, let me see here. So here, as you can see, I have my character. To me, it's like it really simulates quite well, like a real chain. So maybe we can do, just to have some fun, we can actually attach it to this platform. So let's see what it does. I haven't actually tried that before, so it would be interesting to see. Component name. So we have the ledge, the platform here, and then we have the chain. And as you can see, it's already blue. That's because we still had the name here. So let's play now. Yep. As you can see, it's quite fun because it pulls. Let me pull from this. Sorry. So as you can see, it pulls everything. It acts basically like a rope, but it's a chain with elements, as you can see. So if you go, go here, you can even have the cube on it. Yeah. So it's pretty stable, I would say. We have a stomp function. Let me see. This is a stomp when I stomp on the platform. So it's quite stable. Yeah. So yeah, I guess that's it. So it's I would say it's really simple to implement, and it's really good for everything that if you want to connect like different objects. As you can see here, you just put a physics constraint actor. If you want, you can even generate it on the fly, and then you just set it up like this. And yeah. Okay, so that's it. So yeah, thanks for watching, and then I'll try to do more tutorials in the future. I don't know. Let me know. Maybe I'll have to put in place Patreon or something like that. It's kind of hard to do them in my free time because it takes a lot of time. Usually the preparation and all that. So let me know if something like a Patreon would be interesting, and maybe you can choose your own tutorials that you would like me to do. So yeah, that would be interesting. Let me know in the comments. That would be really interesting to interested to know. And also, if you want this pack, you can get it from Fab in just check it out in the video description. So thank you everyone, and see you in the next one.